Altitude. A height is defined based on the context in which it is used. As a general definition, altitude is a distance measurement, usually in the vertical or up direction, between a reference datum and a point or object. The reference datum also often varies according to the context, although the term altitude is commonly used to mean the height above sea level of a location. In geography, the term elevation is often preferred for this usage. Vertical distance measurements in the down direction are commonly referred to as depth. In aviation, the term altitude can have several meanings, and is always qualified by either explicitly adding a modifier, or implicitly through the context of the communication. Parties exchanging altitude information must be clear which definition is being used. Aviation altitude is measured using either mean sea level or local ground level as the reference datum. Pressure altitude divided by 100 feet as the flight level, and is used above the transition altitude in the U.S., but may be as low as 3,000 feet in other jurisdictions. So when the altimeter reads 18,000 feet on the standard pressure setting, the aircraft is said to be at flight level 180. When flying at a flight level, the altimeter is always set to standard pressure. On the flight deck, the definitive instrument for measuring altitude is the pressure altimeter, which is an aneroid barometer with a front face indicating distance instead of atmospheric pressure. There are several types of aviation altitude. Indicated altitude is the reading on the altimeter when it is set to the local barometric pressure at mean sea level. In UK aviation radiotelephony usage, the vertical distance of a level, a point, or an object considered as a point, measured from mean sea level, this is referred to over the radio as altitude. Absolute altitude is the height of the aircraft above the terrain over which it is flying. It can be measured using a radar altimeter, also referred to as radar height, or feet, meters above ground level. True altitude is the actual elevation above mean sea level. It is indicated altitude corrected for non-standard temperature and pressure. Height is the elevation above a ground reference point, commonly the terrain elevation. In UK aviation radiotelephony usage, the vertical distance of a level, a point, or an object considered as a point, measured from a specified datum, this is referred to over the radio as height, where the specified datum is the airfield elevation. Pressure altitude is the elevation above a standard datum air pressure plane. Pressure altitude is used to indicate flight level, which is the standard for altitude reporting in the U.S. in Class A airspace. Pressure altitude and indicated altitude of the same when the altimeter setting is 29.92 Hg or 1013.25 millibars. Density altitude is the altitude corrected for non-ISA International Standard atmospheric conditions. Aircraft performance depends on density altitude, which is affected by barometric pressure, humidity and temperature. On a very hot day, density altitude at an airport may be so high as to preclude takeoff, particularly for helicopters or a heavily loaded aircraft. These types of altitude can be explained more simply as various ways of measuring the altitude. Indicated altitude, the altitude shown on the altimeter. Absolute altitude, altitude in terms of the distance above the ground directly below. True altitude, altitude in terms of elevation above sea level. Height, altitude in terms of the distance above a certain point. Pressure altitude, the air pressure in terms of altitude in the international standard atmosphere. Density altitude, the density of the air in terms of altitude in the international standard atmosphere. In atmospheric studies, atmospheric regions, the Earth's atmosphere is divided into several altitude regions. These regions start and finish at varying heights depending on season and distance from the poles. The altitude stated below are averages. Troposphere, surface to 8,000 meters at the poles, 18,000 meters at the equator, ending at the tropopause. Stratosphere, troposphere to 50 kilometers. Mesosphere, stratosphere to 85 kilometers. Thermosphere, mesosphere to 675 kilometers. Exosphere, thermosphere to 10,000 kilometers. High altitude and low pressure regions on the Earth's surface that are high above mean sea level are referred to as high altitude. High altitude is sometimes defined to begin at 2,400 meters above sea level. At high altitude, atmospheric pressure is lower than that at sea level. This is due to two competing physical effects: gravity, which causes the air to be as close as possible to the ground, and the heat content of the air, which causes the molecules to bounce off each other and expand. High altitude and low temperature. The temperature profile of the atmosphere is a result of an interaction between radiation and convection. Sunlight in the visible spectrum hits the ground and heats it. The ground then heats the air at the surface. If radiation were the only way to transfer heat from the ground to space, the greenhouse effect of gases in the atmosphere would keep the ground at roughly 333 K, and the temperature would decay exponentially with height. However, when air is hot, it tends to expand, which lowers its density. Thus, hot air tends to rise and transfer heat upward. This is the process of convection. Convection comes to equilibrium when a parcel of air at a given altitude has the same density as its surroundings. Air is a poor conductor of heat, so a parcel of air will rise and fall without exchanging heat. This is known as an adiabatic process, which has a characteristic pressure-temperature curve. As the pressure gets lower, the temperature decreases. The rate of decrease of temperature with elevation is known as the adiabatic lapse rate, which is approximately 9.8 degrees Celsius per kilometer of altitude. Note that the presence of water in the atmosphere complicates the process of convection. Water vapor contains latent heat of vaporization. As air rises and cools, it eventually becomes saturated and cannot hold its quantity of water vapor. The water vapor condenses and releases heat, which changes the lapse rate from the dry adiabatic lapse rate to the moist adiabatic lapse rate. Defines an international standard atmosphere, with a temperature lapse rate of 6.49 degrees Celsius per kilometer. The actual lapse rate can vary by altitude and by location. Finally, note that only the troposphere of altitude in the Earth's atmosphere undergoes convection. The stratosphere does not have convection. Effects on organisms. Humans medicine recognizes that altitudes above 1,500 meters start to affect humans, and there is no record of humans living at extreme altitudes above 5,500–6,000 meters for more than 2 years. As the altitude increases, atmospheric pressure decreases, which affects humans by reducing the partial pressure of oxygen. The lack of oxygen above 2,400 meters can cause serious illnesses such as altitude sickness, high-altitude pulmonary edema, and high-altitude cerebral edema. The higher the altitude, the more likely are serious effects. The human body can adapt to high altitude by breathing faster, having a higher heart rate, and adjusting its blood chemistry. It can take days or weeks to adapt to high altitude. However, above 8,000 meters altitude, acclimatization becomes impossible. There is a significantly lower overall mortality rate for permanent residents at higher altitudes. Additionally, there is a dose-response relationship between increasing elevation and decreasing obesity prevalence in the United States. In addition, the recent hypothesis suggests that high altitude could be protective against Alzheimer's disease. disease via action of erythropoietin, a hormone released by a kidney in response to hypoxia. However, people living at higher elevations have a statistically significant higher rate of suicide. The cause for the increased suicide risk is unknown so far. For athletes, high altitude produces two contradictory effects on performance. For explosive events, the reduction in atmospheric pressure signifies less atmospheric resistance, which generally results in improved athletic performance. For endurance events, the predominant effect is the reduction in oxygen, which generally reduces the athlete's performance at high altitude. Sports organizations acknowledge the effects of altitude on performance. The International Association of Athletic Federations, for example, marks record performances achieved at an altitude greater than 1,000 meters with the letter A. Athletes also can take advantage of altitude acclimatization to increase the performance. The same changes that help the body cope with high altitude increase performance back at sea level. These changes are the basis of altitude training, which forms an integral part of the training of athletes in a number of endurance sports including track and field, distance running, triathlon, cycling and swimming. Other organisms' decreased oxygen availability and decreased temperature make life at high altitude challenging. Despite these environmental conditions, many species have been successfully adapted at high altitudes. Animals have developed physiological adaptations to enhance oxygen uptake and delivery to tissues, which can be used to sustain metabolism. The strategies used by animals to adapt to high altitude depend on the morphology and phylogeny. For example, small mammals face the challenge of maintaining body heat in cold temperatures, due to the small volume to surface area ratio. As oxygen is used as a source of metabolic heat production, the hypobaric hypoxia at high altitudes is problematic. There is also a general trend of smaller body sizes and lower species richness at high altitudes, likely due to lower oxygen partial pressures. These factors may decrease productivity in high-altitude habitats, meaning there will be less energy available for consumption, growth, and activity. However, some species, such as birds, thrive at high altitude. Birds thrive because of physiological features that are advantageous for high-altitude flight.